For a long time, black holes were imagined as immovable giants sitting quietly at the centers of galaxies. Their immense gravity was thought to keep everything in place, stars, gas, and dust all bound tightly under their influence. They were considered stable, unchanging anchors that shaped the structure of entire galaxies. The idea that one of these massive objects could actually move through space seemed almost impossible. That view has changed. Astronomers have now identified a black hole doing something completely unexpected. It is racing through space at extraordinary speed, fast enough to break free from its original galaxy. Instead of remaining fixed, it has become a runaway object, launched into the vast emptiness between galaxies. This kind of event is believed to begin with extreme cosmic violence. When galaxies collide, their central black holes can interact in complex and unpredictable ways. In rare situations involving multiple black holes, their intense gravitational forces can act like a slingshot. One black hole may be flung outward at incredible speed, escaping the system entirely. What makes this discovery even more fascinating is that the black hole did not leave quietly. As it travels, it creates a long, glowing trail stretching across an enormous distance, longer than the diameter of our own galaxy. This trail is not just a leftover mark, it is alive with activity. Within this luminous path, new stars are forming. This is surprising because black holes are usually associated with destruction. They consume matter, tear apart stars, and warp space itself. But here, the opposite is happening. As the black hole speeds through thin clouds of gas, it compresses the material in front of it. This compression increases the density of the gas, causing it to cool and collapse. Over time, this process leads to the formation of new stars. In a sense, the black hole is acting like a cosmic engine of creation, pushing material forward and leaving behind a trail filled with newborn stars. It reveals a side of black holes that scientists had not fully appreciated before, that even the most destructive forces in the universe can contribute to creation under the right conditions. Careful observations using powerful telescopes allowed scientists to confirm this phenomenon. Detailed imaging revealed both the fast-moving black hole and its glowing, star-forming trail, strengthening confidence in the discovery. At the same time, researchers have been studying another extraordinary object, a distant galaxy formed from a massive collision long ago. This galaxy shines with incredible energy, far brighter than typical galaxies, with most of its light hidden in infrared wavelengths. Deep within it, dense clouds of gas and dust are packed together, creating perfect conditions for intense star formation. The aftermath of its violent past is still visible. Long streams of gas extend outward, pulled apart by gravitational forces during the collision. These streams contain complex molecules, some of which are considered important building blocks for life. Over time, such material can travel vast distances, eventually becoming part of new stars, planets, and possibly even future life systems. This ongoing cycle shows how the universe constantly reshapes itself. Destruction leads to creation, and chaos gives rise to new structure. Galaxies collide, break apart, and rebuild. Matter is recycled again and again across cosmic time. These discoveries are pushing scientists to rethink earlier ideas about how galaxies form and evolve. Some evidence suggests that structures in the universe may have developed faster than previously believed. New theories are being explored to better match what we are now observing. Modern telescopes continue to uncover details that were once beyond reach. With each new observation, our understanding grows, but so do the questions. The universe is proving to be. There is still much we do not know. Countless mysteries remain hidden in the depths of space, waiting to be discovered. As technology advances, we will be able to look deeper and see further, revealing phenomena we cannot yet imagine. Beyond these discoveries lies an even deeper mystery. What happens to a black hole once it has been thrown out into intergalactic space? Cut off from its home galaxy, the runaway black hole enters a region where matter is far more sparse. Unlike the dense environments at galactic centers, intergalactic space offers very little fuel. Over time, the black hole may begin to quiet down. No longer surrounded by swirling disks of bright, hot material, it could become almost invisible, detectable only through subtle gravitational effects. But its journey is far from meaningless. As it continues to move, it may pass through isolated clouds of gas drifting between galaxies. Each encounter has the potential to repeat the same process: compression, cooling, and star formation. In this way, a single ejected black hole could seed new regions of star birth across vast cosmic distances, influencing areas that would otherwise remain dark and inactive. This raises a fascinating possibility. Some stars in the universe may owe their existence to black holes that were violently expelled from their galaxies billions of years ago. Meanwhile, the galaxies left behind are also forever changed. When a central black hole is ejected, the balance of the galaxy shifts. These massive objects normally help regulate star formation by controlling the flow of gas through their energy output. Without them, the galaxy may evolve differently, perhaps forming stars more rapidly, or losing its structure over time. In cases where multiple black holes were involved, the remaining ones may eventually merge. When they do, they release enormous amounts of energy in the form of gravitational waves, ripples in spacetime that travel across the universe. These waves carry information about the collision, allowing scientists to study events that cannot be seen directly. The discovery of a moving black hole also hints at how chaotic the universe can be on the largest scales. What once seemed stable and predictable is now understood to be dynamic and sometimes violent. Entire galaxies collide, black holes are flung into space, and new stars ignite in their wake. And yet, this chaos follows deeper physical laws. Gravity, motion, and energy interact in precise ways, shaping everything from the smallest particles to the largest cosmic structures. By studying these extreme events, scientists are uncovering the rules that govern the universe itself. There is also a broader implication. If black holes can travel between galaxies, they could play a role in connecting different regions of the universe in ways we had not considered before. They may transport energy, influence matter distribution, and even contribute to the evolution of large-scale cosmic structures. Future observations will be crucial. More powerful telescopes and detectors will search for additional runaway black holes and their glowing trails. Each new example will help confirm whether this is a rare event, or a common but previously unnoticed phenomenon. As our view expands, one thing becomes clear: the universe is not static. It is constantly changing, reshaping itself through both violent and creative processes. Black holes, once seen only as destroyers, are now revealing themselves as complex players in this cosmic story. And somewhere out there, in the silent darkness between galaxies, more of these wandering giants may already be on the move, leaving behind trails of light, and quietly building new stars in the vast unknown. And still, an even more unsettling question begins to emerge from all of this. What if we have only witnessed the beginning of something much larger? The discovery of a fast-moving black hole challenges more than just old assumptions. It hints that the universe may be far more interconnected and active than we ever imagined. If one black hole can be ejected and continue shaping space far beyond its galaxy, there may be countless invisible travelers crossing the void right now. Some could be ancient, launched billions of years ago during the early formation of galaxies, still moving through space with nothing to slow them down. Over time, their paths might intersect with new galaxies, new gas clouds, or even other black holes. Each encounter could trigger entirely new chains of cosmic events, collisions, bursts of radiation,